Good day, folks. Welcome to Bright Mind Academy, where we bring brilliance to every lesson. In today's video, I want us to look at May-June 2024 question paper. And this was, written by those who were rewriting in that particular year thereof. Okay, so yes. So it says now the number of pages in 10 A4 and their corresponding weight are given in the table below. The data is also represented in the scatter plot given thereof. Okay, and then we have that, we have that, we have that, we have that. Okay, let me do this. So 1.1, determine the equation of the least square regression line. Guys, this one need you to it just need you to use your calculator. You know how to find the equation of a least square regression line. Again, you just say mode then press stats on whatever calculator it is. For me, it is 3, and then you'll choose 2a plus bx, and then it will give you an option to insert your data thereof. The x are the x, the y are the y's. Cool. So now, if we do that quickly, we get that the least square regression line, it is this one, negative 43.72 plus 2.36x. You can quickly confirm that if your answer is the same as mine now. And then this for 3 marks. Determine, okay, so draw the least square regression line on the scatter plot in the answer book. So now I'm going to draw it here. So what do they mean? They want me to draw the least square regression line of the scatter plot. Okay, the least square regression line on the scatter plot in the answer book. So what is now the least square regression line? It's just the line of the best fit. How can I draw my line of the best fit? I can choose any point on my graph, any 2 points on my graph to join. Any points on my graph to join. Okay, yeah. And since well now my graph, can you see that my graph is between this? Okay, never mind. Let me just try to draw that. So I'll choose these 2 points. I see which point I want to choose these 2 because they are exactly on the thing thereof. I think I'll choose this one as well as the last one there. Yeah, I'll choose these 2. And then I'll use my pen to try to draw that for us. I'll use a blue one so that you can differentiate. So I can choose, okay. Let me choose those 2 points. Okay, let me redraw that again. Okay, I think this will be fine. So this is what I can draw from my least square regression line. And then let's answer the questions, guys. Remember, we are trying to make you see how these questions are answered. The answers that I might get and might not necessarily be the same as those the memo gets. Okay, so yeah. Then they say predict the weight of an A4 book that has 110 pages. So 110 pages, it is what the X. So I'm gonna be using what my graph, not my graph basically, but my equation here to predict the number of pages thereof. So I'm gonna say the number of pages thereof, the weight of those number of pages is gonna be negative 43.72 plus 2.36 multiplied by 110. Okay, and then I get something like 215.88. Okay, this is the weight. I can say kilogram when I want to, or it is basically in grams. So it's just that And then they say to you, calculate the percentage weight increase between a book with 110 pages and a book with 130 pages. So for you to calculate the percentage increase, guys, percentage increase, it is the new minus the old divided by the old times 100. This is the formula. Whether you are doing life science, physical science, when they say percentage increase, you're going to be using this formula. So now we need the weight, the new weight, okay? Between what? Or the increase from 110 to 130 pages. So the old weight we already have, which is 215.88, right? And then I'm going to divide by that old one, which is 215 point what? 0.88. And then I need to multiply that by 100. But now I need to find what is the new weight when now this one is new when the pages are 130. This one is old when the pages are 110. So it's going to be what? When I just put this on my calculator and predict 130, it's going to be how much? It's going to be, okay, negative 43.72 plus 2.36 times 130. And I get something like 263.08. And then I can just punch it here and say the new one, it is 263.08. Okay. And then I get a percentage increase of something like 21.86. 21.86, guys. Okay. Yes, that's basically that. Move on to question 2. They tell me that 50 athletes need to access suitable training facilities. The table below shows the distance in kilometer that they travel to obtain access to sustainable training facilities. Okay, sharp. This is the grouped data, and then this is the number of athletes in each group data, in each distance. So they say to us, complete the cumulative frequency column in the provided book. So now I'm going to complete it, the cumulative frequency column. So the first one is going to be that number 3, and then 3 plus 7, it is 10. 10 plus 20, it is 30. 30 plus 12, it is 42. 42 plus this, it is 40, sorry. 47. 47 plus this one, it is 50. And it is cool because they have told you that how many? 50 athletes. So can you see that? Yes. So this is my cumulative frequency graph or data. Okay. And then on the grid, okay, actually I did take it. So I'm going to say it is 3, 10, 80, 42, 47, and 50. And then they asked me that on the grid provided, draw a cumulative frequency graph, an ogive, to represent the data. Let's try to draw that ogive, guys, beautifully. So we're going to say, this is how you start, guys. These are the things that you're going to need, ne? Always. So it means 0, it will be your ground. 0. The number here will be your ground. What do I mean it will be your ground? It will be your point here, 0, 0. If the number here was 2, it means on the distance, we would have grounded at 2. Okay, yes. And then we say 5 goes with 3. This is cumulative frequency. So 5 goes with 3. Let me do this. 5 goes with 3. 5 goes with 3. And then 10. I'm looking at these guys. 10 goes with what? Can you see 10, 10? So let me quickly do that. 10 and 10. Quickly do that. 10 and 10. Zoom so that I plot beautiful stuff. 5 and 3, 10 and 10. 15, 30. Where's 30? I can see. 15, 30. And then 2042. 2042. 25, 47, 25, 47, 25, 47. And then the last one, it is 30, 50 again. So for now, I've just plotted my points. All I need to do from now on, from these points thereof, it is to do what? To try to join the points beautifully. This is what I can get, guys. This is the best that I can get. I want to redraw trying this. And yeah, that's that. I'm done. And then let's answer the follow-up question. Guys, what's important is that it should ground at 0, 0. It is a mark that it grounds at 0, 0. Again, and then plotting, and then just getting your smooth curved shape. Remember, it is an ogive. It is an ogive. So let's try to answer the questions, guys, that fold. Calculate the interquartile range of the data. What is the interquartile range? Remember, interquartile range, it is Q3 minus Q1. So we basically need to start and find our Q1 and Q3. How do you find your Q1? Remember, for you to find your Q1, you need the position of Q1. Okay, the position of Q1 is gonna be 1 divided by 4 multiplied by n, which is what? Which is this one here, which is 50. So it's gonna be, the position is gonna be 12.5. So I need to locate 12.5 on my graph. I need to locate 12.5. So this is 12.5, it is somewhere here. And then I get something like 11. Yeah, this is what I get, guys. I get something like 11. So my quartile 1, it is 11. And then I need to find the position of the higher quartile, which is upper quartile, quartile 3. Quartile 3, quartile 3 position, quartile 3 position is going to be 1 over 3 over 4 multiplied by 50, which is basically 25 plus 12, it is 27.5. 25.5, I think. Yeah, 37.5. So the position it is 37.5. I need to locate 37.5. So if this is 36, 7, and then 37.5 somewhere here in the middle. Okay. And then when I move a little bit downwards the off, I get it to be something like okay, I get it to be something like, let me see, 16, 17, 18. Almost 18, but not necessarily 18. 17.8 maybe. 17.8 maybe, 17.6, 17 point what. So I'm going to say, okay, my quartile 3, it is 17.8. Okay, and then I can now calculate my interquartile range. My interquartile range is going to be my quartile 3, which is what? 17.8 minus what? 11, which is 6.8. Okay, 6.8. 6.8. Here, guys, for your quartile 1, we can, for quartile 3, we can accept, I think it is acceptable for you to be between 17 and 19, maybe, I don't know. And then for this one, maybe you're allowed to be between 10 to 12, maybe 10 to 12. You don't need to be precise because we won't always be precise in everything that we do, okay? It says to us, the family of 4 of the athletes above who stay between 15 and 20 kilometers from a suitable training facility decided to move 10 kilometers closer to the facility, okay, 10 kilometers closer. So if you were going from 15 to 20, guys, if your kilo was, you were traveling 15 to 20, and then you decided to move 10 kilometers closer, it means now you are decreasing the proximity, the distance. So it means now your distance will now be what? Minus 10 is going to be now 5 kilometer 10. So the question is, in which interval will the number of athletes increase? In which interval will the number of athletes increase? Well, since when these people are moving from this one here, they are moving from 15 to 20, 15, 20, they are moving to what? To 10, to 5, 6, 5, 10. So which interval will increase? The interval that will increase will be 5 and 10. We'll just answer that by saying, okay, it is 5x 10, like that again. Don't forget there's an equal sign there off. and then, and then. They say now, calculate the estimated mean distance that the 50 athletes need to travel after 4 families have moved 10 kilometers closer to the thingy. After 4 families have moved 4 kilometers closer to the facility, they clearly show all your king. So the estimated mean, guys, estimated mean, we'll need our new frequencies. So our frequency will move. So they said 4 families, 4 families of the athletes. So it means here it will no longer be 12, but it is now what? 8. And then here it will no longer be 7, but now what? 11. Okay. So we need to find the what? The new cumulative frequency for those people. Let me reshuffle it here. The new one will now be, okay, these people here are no longer 12, but they're now 8. These ones are no longer 7, but they are now 4. Remember here we subtract 14, 4 families, and then we add 4 families here. This is not 11, guys. I guess. So our new cumulative frequency will now be 3, then 3 plus this, it is 14, 14 plus 20, it is 34, 34 plus 8, it is 42, 42, okay, then everything will start moving fine again. So, but we will be using what? We will be using this one to find our estimated mean. These ones to find our estimated what? Our estimated mean. How do you find the estimated mean? You will need your midpoint multiplied by frequency. Midpoint multiplied by frequency column. Okay. Midpoint multiplied by frequency column, which is basically what? What is my midpoint? It is the midpoint between these two values here. Can you see? They say estimated mean. So the mean value, okay, the number between these two numbers, you're gonna say 0 plus 5 divided by 2. You will get 2.5, 7.5, 12.5, 17.5, and then 22.5, 27.5. That's that. And then these are what we're gonna multiply. Okay, I'm gonna multiply the green with the green. Okay, so it's gonna be what is this? These multiply by those. Okay, so the first one, it is 2.5 multiplied by 3. 2.5 every time when we have a grouped data, guys, a grouped data like this, we find the estimated mean. 2.5 multiplied by 3, it is 7.5. And then 7.5 multiplied by 14, 105. And then 12.5 multiplied by 34, 425. And then 17.5 multiplied by 42, 730. Mudimo. I feel like it's becoming too much now. Guys, midpoint multiplied by frequency. not a cumulative frequency. So midpoint multiplied by frequency. I'm hard. So sorry guys about that confusion. It's gonna be midpoint multiplied by frequency. Our frequency the of is 1. Midpoint multiplied by frequency. We only use cumulative frequency to draw a graph. Okay, yes. Then I repeat again. Sorry, it's gonna be 2.5 multiplied by 3, still my 7.5. 7.5 0.5 multiplied by 11, 82.5, 12.5 multiplied by 20. Guys, you need to multiply by the new frequencies. Can you see the new frequencies here? The new frequency, not the 7, but now they changed one. Okay. And then 17.5 multiplied by 8, 140. And then 22.5 multiplied by 5, 112.5. And then the last one, 27.5 multiplied by 3, 82.5. When I add all of that, I get a total frequency of 675. And then I know that the total frequency here, it is how much? It is 50. So my estimated mean, when I calculate my estimated mean, estimated mean is gonna be the sum of midpoint multiplied by frequency divided by number of things the of, okay? Total number of frequency. And then it's going to be what? We said the number that we get, the total, this one's 675, all divided by 50. And then the estimated mean will be something like 18.5 kilometers. It's very important, guys, that you know how to do this. It's very, very important to know how to do that. Okay. So yeah, guys, that's basically that for this question. Nothing difficult. So yeah, I hope you enjoyed and understood. Thank you.